Hey there! Thanks for watching this video. This video is created based on my talk at TestBustersDay in Vienna 2024. The name of this talk is Managing Your External Data Dependencies. My name is Roy, and I have over 15 years of experience in technical software testing. My work includes functional test automation of web applications, mobile applications, and APIs, as well as evaluating the performance of those systems. I'm working as a trainer in combination with some smaller part-time assignments. Currently, some businesses in the finance domain, as well as Auticom. Auticom is the world's largest employer of neurodivergent talent. Besides that, I'm also the creator of PracticeSoftwareTesting.com, an incremental software testing learning application. With this presentation, I like to show you a way how you can deal with external data dependencies, reflected to the software testing pyramid. It is by no means a silver bullet. It is just my reflection on how you can test in an effective way. Before we dive into the content, I want to mention that I developed an application especially for this talk. The name of the application is Can I Wear Shorts? It answers the question if the temperature is high enough to wear shorts. It exists out of a Java Spring Boot backend that retrieves data from an external service, an Angular frontend, and a local in-memory database. This is the software testing pyramid, the idea of which came originally from Mike Cohn. Nowadays, there are different flavors of this model. For the sake of simplicity, I took this one. Two things that are common for all models, and you should remember. You can test from different perspectives and layers. The higher you get, the fewer tests you should have. Finding the right balance between these layers would give you the most optimal feedback cycle. I want to guide you through each layer of the software testing pyramid. Let's explore the first layer, unit testing layer. Let's discuss the characteristics and benefits of this layer. To start with the characteristics. Tests in this layer test the smallest public-facing parts of the application. Private parts are not accessible for the unit testing framework, and these parts are generally called from the public-facing parts. These tests run during the build time of an application, obviously without the application being deployed. The developers usually write these during the development phase. Mature development teams write the unit tests even before the application code, using a methodology called TDD. Testers can help increase unit testing coverage. Unit tests are written in the same programming language as the application itself, like JUnit, NUnit, PHP unit, Jest, iTest. The benefits of these tests are: they run extremely fast, because they are running during build time. They isolate failures. Tests cover the smallest parts of an application, so if a unit test fails, you immediately know where to look. The exact line character number is shown. The higher you get in this software testing pyramid, the more unclear it will be. Those tests have the least dependency on test data, because all data can be mocked or stubbed, which I show you later on. It enforces a testable application design. This can be achieved by applying design patterns. Guided by some cases, I want to show you some unit tests. This case is about some code that integrates with an external service that returns the temperature in Kelvin. Here, we are setting up the necessary objects for the test. The REST template is being mocked using Mockito. which means we're creating a mock version of this class to control its behavior during the test. This mock object is then passed to the constructor of weather service to create an instance of weather service. This setup allows us to test weather service without making actual HTTP calls. In these lines, we create an instance of weather response and set its temperature property to 300 Kelvin. This weather response object is used to simulate the response that would be returned by the REST template when it makes an HTTP call. This line sets up the behavior of the mocked REST template. It specifies that when the getForObject method is called with any URL and the weather response class as parameters, it should return the mock response object we created earlier. This simulates the HTTP response that the weather service would receive when making a real call. Here, we call the getCurrentTemperature in Celsius method on the weather service instance. This is the method under test. The method should internally use the mocked REST template to get the weather response, convert the temperature from Kelvin to Celsius, and return the result. This line captures the returned temperature in Celsius. This is a case about the code that is responsible for registering an account. There are two business rules. 1. Email address should be unique. 2. Age should be over 18. Let's start with a success scenario. In these lines, we're using the Faker library to generate random data for a new user account. Specifically, we're generating a first name, last name, email address, and password. This random data will be used to create a new user object for the test. Here, we use the Faker library again to generate a random birth date for the new user. The birthday method generates a date for a person aged between 18 and 100 years. The date is then converted to a local date object, which will be used to set the birth date of the new user. These lines set up the behavior of the mocked user repository. The first when statement specifies that when findByEmail is called with the generated email, it should return null, simulating that no existing user with that email is found. The second when statement specifies that when save is called with any user object, it should return the user object, simulating the successful saving of the new user. This line calls the register new account method on the registration service with the new user object. This is the method under test. The method should internally use the mocked user repository to check if the user already exists and to save the new user. The registered user object returned by this method is captured in registered user. These lines are assertions to verify that the registered user object is not null and that its properties match the values that were set for first name, last name, email, password, and birth date. This ensures that the user was correctly registered and that the registered new account method works as expected. Let's create another test for an underage user. These lines generate the necessary test data for the new user account using the Faker library. They create a first name, last name, email address, and password. This generated data simulates real user input for testing purposes. This line generates a birth date for the new user, ensuring that the user's age is between 0 and 17 years old. The birthday method from the Faker library generates a date within this range, and the date is converted from a date to a local date using time zone conversion. This simulates the scenario of a user who is underage. Here, we create a new user object using the generated data. This user instance represents the underage account that we want to register. It encapsulates all the necessary information about the user. This line sets up the mock behavior for the user repository. It specifies that when the findByEmail method is called with the generated email, it should return null, indicating that no existing user is found with that email. This simulates the scenario where the email is not already in use. In this line, we call the register new account method on the registration service with the new user object. We expect this method to throw an illegal argument exception because the user is underage. The assert_throws method is used to capture the thrown exception, ensuring that the correct exception type is thrown. This line checks the message of the thrown illegal argument exception to ensure it matches the expected error message. User must be 18 or older. This assertion verifies that the exception thrown by the register new account method provides the correct feedback for an underage user. The final case is for an existing email. In this line, we're using the Faker library to generate a random email address. This email will be used to simulate an existing user in the database. Here, we create a new user object named existingUser and set its email property to the generated email. This user simulates an already existing user in the database with the given email address. This line sets up the behavior of the mocked user repository. It specifies that when the findByEmail method is called with the generated email, it should return the existing user object. This simulates the scenario where a user with the specified email already exists in the database. In these lines, we create a new user object named newUser with random values for the first name, last name, password, and a birth date 20 years ago. The email for this user is the same as the one generated earlier, simulating an attempt to register a new account with an email that already exists in the database. Here, we verify that the exception message is user already exists. This assertion checks that the register new account method correctly throws an illegal argument exception with the appropriate message when attempting to register a user with an already used email. I have used the following tools: JUnit as the testing framework, Mockito for my test doubles, DataFaker to generate fake random data. Let's dive into the second layer of the software testing pyramid, the API layer. Also for this layer, I like to discuss the characteristics and benefits. To start with the characteristics. Tests in this layer test the integration of multiple units that are exposed through an HTTP service. Typically, a running application is needed because you like to interact with the application over the HTTP protocol. These kinds of tests can be written in your favorite programming language or even a low or no code tool. The benefits of these tests. They are also fast if compared to user interface tests. You can detect issues early on because business logic, data processing, and integration are included with this kind of testing. These tests are also cost-effective. Identifying and fixing issues here is much cheaper and faster than using the user interface tests. Also, here to explain tests in this layer, I have several cases with examples. The first case, I want to test if I can register a new account and check if the data is stored correctly in the database. In these lines, we are setting up the necessary data for the test. Using the Faker library, we generate random values for first name, last name, email, password, and birth date. This random data is used to create a new user object, newUser, which will be sent in a registration request. In these lines, we simulate an HTTP POST request to the users/register endpoint using the REST assured library. The request sends the new user object as JSON. We expect a 201 created status code in response, indicating that the user was successfully created. Additionally, the response body should contain the email of the newly registered user. The response is then extracted and stored in the response variable. In these lines, we verify the test results. First, we assert that the response is not null, ensuring that we received a response from the server. Then, we check the database by calling find by email to find the newly registered user. We assert that the user is present in the database and that the user's details, first name, last name, email, password, and birth date, match the values we originally set. The next case is to test how the application responds to different temperatures and errors. These lines define the query parameters for the HTTP request. The city parameter must be equal to London. This setup is part of the request configuration, specifying that the endpoint should only match requests where the city query parameter is exactly London. These lines define the response body and headers. The response body is a JSON string containing a temperature key with a value of 300, which represents the temperature in Kelvin. This line initiates an HTTP GET request to the API/temperature endpoint with a query parameter city equal to London using the REST assured library. The response from this request is stored in the response variable. This line specifies the expected HTTP status code of the response. The test expects a 200 OK status code, which indicates that the request was successful. This line verifies the server's response. It asserts that the temperature value in the JSON response body is equal to 26.85 Celsius, with a tolerance of 0.01. This value is derived by converting the Kelvin temperature from the response body to Celsius, returning a different temperature. These lines define the query parameters for the HTTP request. The city parameter must be equal to Paris. This setup is part of the request configuration, specifying that the endpoint should only match requests where the city query parameter is exactly Paris. These lines define the response body. The response body is a JSON string containing a temperature key with a value of 280, which represents the temperature in Kelvin. This line initiates an HTTP GET request to the API/temperature endpoint with a query parameter city equal to Paris using the REST assured library. The response from this request is stored in the response variable. This line specifies the expected HTTP status code of the response. The test expects a 200 OK status code, which indicates that the request was successful. This line verifies the response from the server. It asserts that the temperature value in the JSON response body is equal to 6.85 Celsius, with a tolerance of 0.01. This value is derived by converting the Kelvin temperature from the response body to Celsius, forcing an error 500. These lines define the query parameters for the HTTP request. The city parameter must be equal to unknown. This setup is part of the request configuration, specifying that the endpoint should only match requests where the city query parameter is exactly unknown. These lines define the response status and body. The response status is set to 500, indicating an internal server error. The response body is a JSON object containing an error key with the value internal server error. This simulates a scenario where the server encounters an error while processing the request. This line initiates an HTTP GET request to the API/temperature endpoint with a query parameter city equal to unknown using the rest assured library. The response from this request is stored in the response variable. This line specifies the expected HTTP status code of the response. The test expects a 500 internal server error status code, which indicates that the server encountered an error while processing the request. This line verifies the server's response. It asserts that the error value in the JSON response body is equal to internal server error. This ensures that the server correctly returns the expected error message when encountering an internal server error, forcing an error 404. These lines define the query parameters for the HTTP request. The city parameter must be equal to nowhere. This setup is part of the request configuration, specifying that the endpoint should only match requests where the city query parameter is exactly nowhere. These lines define the response status and body. The response status is set to 404, indicating that the requested resource, in this case, the city, was not found. The response body is a JSON object containing an error key with the value city not found. This simulates a scenario where the server cannot find the specified city. This line initiates an HTTP GET request to the API/temperature endpoint with a query parameter city equal to nowhere, using the rest assured library. The response from this request is stored in the response variable. This line specifies the expected HTTP status code of the response. The test expects a 404 not found status code, which indicates that the server could not find the requested city. This line verifies the server's response. It asserts that the error value in the JSON response body is equal to city not found. This ensures that the server correctly returns the expected error message when the specified city is not found. I have used the following tools: JUnit as the testing framework, WireMock to mock HTTP responses, Rest Assured as the test library. Not used, but extremely handy: Open API Generator. I have used it in the following situations: mocking the Chamber of Commerce, and also simulating slow responses and error codes. Energy meter reading service to speed up long-running processes. In this case, a specific API request can trigger a process that can take from 2 to 5 days. SMS sending service to reduce costs. We have reached the top layer, the user interface testing layer. Let's discuss the characteristics and benefits of this layer. To start with the characteristics. Slow compared to the other layers. Tests in this layer tend to be brittle. Front end can change frequently and unexpectedly. Small changes can have a huge impact on automated tests, often implemented as DOM to data store, so-called end-to-end tests. Luckily, modern front-end frameworks support component testing, allowing you to test the different components in isolation. Getting the right state of the data can be quite challenging. Benefits of these tests. These kinds of tests allow you to simulate real end-user behavior. Here I like to quote David Burns: "It enables you to test where your users are, and you should do so." You can catch visual issues with tools like Applitools and Percy. And something that becomes increasingly important, you can detect accessibility issues. In 2025, the European Accessibility Act gets presence. Also, here I have two cases. Let's start with the first case where you want to write a test for registration. In these lines, we are setting up the necessary data for the test using the Faker library. Random values are generated for first name, last name, email, password, and birth date. The birth date is generated to be a past date within the last 30 years, before January 1, 2000, and formatted in a specific format. This data will be used to fill out the user registration form. These lines define the actions performed on the web page. First, the test navigates to the registration page using page.go to register. Then, the form fields are filled with the previously generated data using the page.fill function, which selects the input fields by their name attribute. Finally, the form is submitted by clicking the Submit button using page.click. These lines define the assertions to verify that the registration was successful. The test expects the page URL to change to success, indicating that the user has been redirected to a success page. Additionally, it verifies that a success message registration successful is visible on the page. Let's take a look at a different kind of front-end test, an Angular component test. This test doesn't communicate with the backend, but it will test different messages based on different temperatures. The temperature component class in Angular fetches the current temperature from an API upon initialization and stores it in the temperature property, providing a suggestion on whether it is warm enough to wear shorts based on the temperature. It includes methods for fetching the temperature from the API, setting the temperature manually, and a computed property for generating clothing suggestions. This test method sets the temperature to 30 using setTemperature and triggers change detection with fixture.detectChanges. It then queries the DOM to find the paragraph element displaying the temperature and asserts that its text content includes the current temperature is 30. This test method sets the temperature to 25 using setTemperature and triggers change detection. It then queries the DOM to find the second paragraph element and asserts that its text content includes "it is warm enough to wear shorts." This test method sets the temperature to 20 using setTemperature and triggers change detection. It then queries the DOM to find the second paragraph element and asserts that its text content includes "it is too cold to wear shorts." In this case, I only used Playwright. Knowing the characteristics and benefits of each layer of the software testing pyramid enables you to get the most optimal feedback cycle. Usually, the higher you get, the more integrated parts you test. But it's good to know that modern front-end frameworks and testing tools give you the option to do component testing. Thank you so much for watching this video. I hope you can apply some of these in your daily work.